Well, this is something that really is a once-in-a-lifetime event for so many people. The Earth, the Moon, and the Sun are going to line up perfectly so that the Moon actually blocks out the Sun and casts a shadow down on the Earth. And there's about a 70-mile path that is going to go all the way across the United States. It's going to start at Portland, Oregon, and actually exit in Charleston, South Carolina. And in that one little strip, the sky will go entirely dark. The Moon will entirely cover up the Sun. But even if you're not in that strip, you're going to see something called a partial solar eclipse. So different levels of the Sun will be blocked depending on where you are in the United States. But everyone in the United States has a chance to view this and participate in this wonderful natural event. Well, if you're lucky enough to actually be in the path of totality, it's something that changes your life. I've seen two total eclipses of the Sun. And the sky goes entirely dark, the Moon covers up the Sun, and you're able to see something called the solar corona, which is the atmosphere of the Sun. So you see these streamers of light coming away from the covered up Sun. And that you can actually see with your unaided eye. You can take off any sort of eye protection when it's totally dark and look up at the sky. You see the stars come out, you see the planets Mercury and Venus near the Sun, and you actually see a 360-degree sunset all the way around you. If you're not in the path of totality, the really important thing is to get some good eye protection. So there are eclipse glasses, and you can actually find out where to get these and how to use them properly on our website. NASA's put together a big website called eclipse2017.nasa.gov. And you can go there to find out how much of the Sun is going to be blocked out in your area, where to get eclipse glasses, and also other ways to view the eclipse safely. Well, the main thing that I really can't iterate enough is that when even a tiny little bit of the Sun is still visible, it can damage your eyes. So unless the Moon is entirely covering up the Sun, you either need eclipse viewing glasses, or you can do something relatively simple called a pinhole camera. And with a pinhole camera, all you need to do is just punch a little hole in a piece of cardboard, or you can actually use something like a colander, a kitchen implement that has little holes in it. You let the sunlight shine through that, and then you look down on the ground at the image that's being projected. And those little holes will actually focus the sunlight, and you'll be able to see a crescent shape. You'll be able to see the Moon blocking out a good portion of the Sun. But do not ever look at the Sun, even if a little bit of the surface is uncovered. If even a little bit of the Sun is not blocked, then the sky will be mainly bright, but you'll notice changes. There'll be changes in the temperature. You'll actually watch animals change. Birds will go back to their nests if it gets quite dark. And one of the amazing things is you can help us take information about this. NASA is going to be taking information about changes in temperature, changes in cloud shapes. We have an app called the Globe Observer. And if you just have a simple, cheap thermometer, if you download this app, you can enter data about how the temperature is changing and how clouds are changing. And we're going to use that to do original science research about how sunlight and the Earth's atmosphere interact. All of the energy that we use on this planet originally comes from the Sun. And it may surprise you to know that something as simple as sunlight is not perfectly understood. Our atmosphere absorbs sunlight, it reflects some. There are different levels of the atmosphere, different colors that are used. So we actually have experiments set up to figure out how much sunlight actually reaches the surface of the Earth. And we have an experiment going to the space station later this year called TESIS, which is going to measure the total amount of sunlight that the Earth receives.